All right, class, in this lesson, we are going to learn to multiply and divide radical numbers. So let's go ahead and get started with our first example. So we're going to start off fairly easy, and we are looking for the product of square root of 2 times 3 square root of 2, okay? Now, when we multiply these together, we can combine the numbers underneath the root sign as one entity, okay? And so this works out to 3 square root of 2 times 2, okay? Notice that both of these values came together under one roof, okay, or under one radical sign. Now, the next step is this comes out to 3 times 2, because when you have two values being multiplied together underneath the radical sign, both of those come out, but when they come out, they're represented as one of the two, okay? And so then this works out to a value of 6, and this becomes our answer. Okay, let's go ahead and take a look at a quotient or division. Here we've got square root of 2 divided by 3 square root of 2. Well, what we see is that there's a square root of 2 in the numerator on top, and a square root of 2 in the denominator on the bottom of the fraction. When you see those, you can actually cancel those out, okay? And we're left with 1, right? Because square root of 2 divided by square root of 2 is essentially 1. It's not 0, so we're going to use 1 as the placeholder. And so our answer becomes 1 over 3. Okay, let's go ahead and move on to example number 2. Here we're looking for the product of square root of 8 times the square root of 12. Again, we can multiply these together and put them under one radical sign. So this equals, oops, let me rewrite that again, 8 times 12, okay? Notice I didn't multiply them together yet. And the reason for that is because we want to break these down into their smaller parts, okay? You could technically multiply them together and then find their smaller parts. And when I say smaller parts, I mean their factors. But that might be a little bit more difficult for some of us, so I'm going to keep this as simple as possible. So the next part of this is finding factors of 8 and 12, okay? The factors of 8 are 2 times 4, and the factors of 12 are 4 times 3. Okay, now, as you might recall from the previous example, when you have two of the same values underneath the radical sign that are multiplied together, okay, this only works with multiplication, when you have two of those, they can come out as 1. Okay, so what that means is this 4 comes out of the radical sign, but it's represented as one of them, and we're left with 2 times 3. Okay, now we can multiply both of these values together, and our final answer becomes 4 square root of 6. Okay, and we multiply those together because these are already prime numbers. We can no longer factor those by anything other than the number 1. Okay, so when you get to that point, then there's nothing else you can do to move them out of the radical sign. Okay, so let's take a look at one involving a division. Okay, so we're taking a look at square root of 8 divided by the square root of 50. Okay, now to do this problem, we're going to break each of the components down to its factors. So the numerator, or the top number, is going to work out to 4 times 2 underneath the radical sign. And then on the bottom, this is going to work out to 25 times 2. Okay, now you might be asking, why 25 times 2 and not 10 times 5? You could do 10 times 5, but it's going to create extra steps to get to the answer. The best thing to do when you're looking at factors is to find factors that have the largest perfect square, okay? 25 here is a perfect square, and it's the only factor with a perfect square, so we're going to choose this one. All right, so then this works out to the following. If you take a look at the top numbers, okay, we have a perfect square in here. And we know that the square root of 4 is 2, right? So that comes out as 2. And we leave the remaining 2 underneath the square root sign. And then working the denominator, we have a perfect square of 25. And we know that the square root of 25 is 5. So that's going to come out of the radical sign. And this ends up becoming 5 square root of 2. Okay? And then lastly, we see that we have a square root of 2 in the numerator and a square root of 2 in the denominator. Like before, we can go ahead and cancel those out, and that becomes 1. Okay? And what I didn't mention earlier is that these can cancel out as long as there's multiplication or division involved in the numerator and the denominator. If I have a plus sign somewhere in here, then you cannot cancel those out. Okay, so then this works out to 2/5. And that's our answer. Okay, moving on to example number 3. What is the product of square root of 16 times square root of 25? Okay, now this problem could be very, very easy or could become much more difficult. The natural thing to do is to bring both of these numbers together and multiply them and then find factors. However, if you recognize that both 16 and 25 are perfect squares, then you could easily find their square roots. Okay, so the square root of 16 becomes 4, and the square root of 25 is 5. And so then my answer here is 20. Okay, now let's take a look at a quotient example. Same scenario. We're going to take the square root of 36 divided by square root of 64, and hopefully you recognize that both 36 and 64 are perfect squares. Okay, so then the square root of 36 we know as 6, and the square root of 64 is 8. Okay, and 6 over 8 both have factors of 2 that can be taken out. Okay, so this reduces to 3/4. Okay, so that works out to be our answer. All right, so let's go ahead and move on to example number 4. Okay, here we've got a bunch of things going on. Okay, our level of difficulty has just gone up. We have the square root of 18 times the square root of 16 divided by the square root of 27 times the square root of 32. Okay, so what we're going to do is find factors of each of these components and then put them together. All right, so the square root of 18 works out to 9 times 2, okay? We chose 9 times 2 because 9 is a perfect square. You could use 6 times 3, but then you'd have to break the 6 down to 2 times 3 to eventually find out that you could pull out a 3, okay? So that's an extra step. And then the square root of 16, we should recognize as 4, so that's just times 4 divided by square root of 27 works out to 9 times 3. Okay, and then the square root of 32 works out to 16 times 2. Okay, you could use 8 times 4, but that again would require an extra step. Okay, 16 times 2 is nice because we already have a perfect square here. All right, so let's go ahead and simplify this. Square root of 9 we know is 3, so that can come out of the radical sign. So that becomes 3 square root of 2. Okay, we're going to leave times 4 as is. We're not going to do anything there yet. And then in the denominator, we see that there's a perfect square of 9. So that comes out as 3. Square root of 9 is 3. So that becomes 3 square root of 3. Okay, times, here we have a 16. That's also a perfect square, so that can come out of the radical sign as 4, because square root of 16 is 4. And this works out to 4 square root of 2. All right, so we see something that we can do to reduce these numbers. There's a 3 in the numerator and a 3 in the denominator. So we can go ahead and cancel those out because they equal 1. And again, we can cancel those out only when there's multiplication or division involved here. Okay? All right, so then this simplifies to 4 times 4 square root of 2 over the square root of 3. Okay, notice that I brought this in together with this, and I'm also missing a square root of 2 right here. So I need to also include that, times square root of 2. All right, so I think we've got all the components. Let's see. We have a square root of 2, which is here. We have a 4, which is here. We have another 4, which is here, and then another square root of 2. That's over here, and then we have the square root of 3 down at the bottom. Okay, so everything is accounted for. All right, so now we can go ahead and rewrite this as 16, right? 4 times 4 is 16, and we have a square root of 2 and another square root of 2, so we can combine those to be square root of 2 times 2. Okay, and that's all over square root of 3. All right, so now we see that we have 2 2's underneath the radical sign. So both of these can come out, and when they do come out, only one is represented. Okay, so then this works out to 16 times 2. There's nothing left in the radical sign, so we don't need to write that, and that's over the square root of 3. Okay, and then that simplifies to 32 over the square root of 3. And we want to use this as our final answer, but the problem with this is that in math, we cannot represent an answer with a square root sign in the denominator. Okay, so we have to change that. And the word to change that is called rationalize. Okay, so we need to rationalize this by getting rid of the square root sign. And the way to do that is to multiply by square root of 3 over the square root of 3. Okay, square root of 3 over square root of 3 is essentially 1. So we're not changing the value of our answer, we're just changing the way it looks. Okay, so when you do that multiplication, okay, this works out to 32 square root of 3 divided by 3. Okay, square root of 3 times square root of 3 works out to just be 3. All right, and this can't be simplified anymore because 3 does not go into 32, and there's nothing else I can factor out. And so this becomes our final answer. Okay, let's move on to example number 5. We're going to simplify the following. Again, we're going to go through the same process with the key thing is finding the best factors of each of these numbers. And the best factors of each of these numbers would be or will be the largest perfect square. Okay, so let's take a look at the first one. We have a negative square root of 72. Okay, we could do 9 times 8 because 9 is a perfect square. However, there's one that's even better, and that is 36 times 2. Okay, 36 is the largest perfect square. That happens to be a factor of 72. Okay, and then working the denominator, we have 3 times the square root of, we could do this as 10 times 6, 12 times 5, but neither of those are perfect squares. However, we could do 4 times 15, where 4 is the perfect square. Okay, and then the third term times 4 square root of factors of 32 would be 16 times 2, where 16 is the largest perfect square. All right, so let's go ahead and simplify this. This becomes negative. Square root of 36 is 6, so we can pull that out. That becomes negative 6 square root of 2 divided by 3 times square root of 4 is 2, so that can come out as 2 square root of 15. Okay, notice that we did a multiplication here because this is already a multiplication. When you pull this out, we're still multiplying, so we need to indicate that as well. Okay, and then the last one, we have a square root of 16, which is a perfect square. That comes out as 4, okay, so it's going to be 4 times 4 square root of 2. Okay, so then simplifying this further, this becomes negative 6 square root of 2 times 16 square root of 2 divided by 6 square root of 15. Okay, now notice that we have a 6 on top and a 6 on the bottom, so we can cancel those out. Okay, but don't forget the negative. Okay, we have to remember to keep that. So rewriting this, we get negative 16 square root of 2 times square root of 2. Okay, I'm just rewriting the order here. We have a negative down here. Then we're going to write, I wrote this next, so that comes over here. And then this square root of 2 comes down here. This square root of 2 comes down here. Okay, so one of the great things about when we have a scenario where everything is being multiplied together, you can change the order. Okay, all right, and then the bottom ends up becoming just square root of 15. Okay, this also works out to negative 16 square root of 2 times 2. Okay, we combine these together under one radical umbrella, and since there are 2 of these underneath the umbrella, that can come out, both of those can come out, but represented by 1. Okay? Okay, so let's go ahead and finish writing the denominator first. That's square root of 15. And so this works out to negative 16 times 2 over the square root of 15, which works out to negative 32 over the square root of 15. And again, we need to rationalize the denominator because we can't leave the radical sign as our answer. So we're going to multiply this fraction by square root of 15 over the square root of 15. And then our answer becomes negative 32 square root of 15 over 15. Okay? This can't be simplified any further. There aren't any factors in 15 that fit into negative 32. And so this becomes our final answer. All right, let's go ahead and work through one last example. Here we're going to simplify negative square root of 100 over 5 square root of 45 times 2 square root of 125. Okay, so the process is the same. We're going to go ahead and simplify the numerator first. And we should recognize that the square root of 100 is 10, so we're going to just represent this as negative 10 because of this negative sign. We have to carry that through. All right, now the bottom is a little bit more complicated. Here we're going to break down square root of 45 into its factors, which would be 9 times 5, okay? And square root of 125 has a factor of 25 and 5. So this works out to negative 10 over 5 times 3 square root of 5. Okay, again, this is a perfect square, so it comes out as 3. Okay, sorry about that. Okay, so let's go ahead and continue. This is going to be times 2 times 5 square root of 5. Okay, and you'll notice that we took the square root of 25 to be 5, so that came out over here. And so simplifying this further, we get negative 10 over 15 square root of 5 times 10 square root of 5. We have a 10 on top and 10 on the bottom, so those can cancel out. And now we're left with negative 1 over 15 times the square root of 5 times the square root of 5, which works out to negative 1 over 15 times 5, right? Because square root of 5 times square root of 5 is just 5, and that works out to negative 1 over 75. Okay, and that is our answer. All right, sorry for the distraction in the last minute or two, but hopefully this made sense to you. If any of this was confusing, please go back to the beginning of the recording and listen to it again. Thank you.